It's always great to be back in this room. This is, one of the earliest classes that I taught was in this room. I had an office in this building about 25 years ago when I joined LUMS. So always great to be back. Last time I was here was only a week ago. We had a startup weekend event for budding entrepreneurs, and we'll get started with the session. The first session is on the blockchain, a practical introduction. We'll just keep it very simple, just give you the foundation of what blockchain is and how digital assets are dependent upon the blockchain. We'll just talk about the basics of the blockchain technology. We talk about Bitcoin and all the cryptocurrency, stable coins, CBDCs, how blockchain plays a fundamental role in establishing those financial instruments or financial items. We'll just talk about that, providing the foundation of what is behind those digital assets and crypto assets. ये चला, ये काम नहीं कर रहा. So credits and thanks on the first slide. All the students and colleagues at the center. Of course, I will not name all of them. So the first session is on the blockchain, very practical introduction to the blockchain. We like to think that Bitcoin and blockchain are the same things. They are completely different. So in this session, we will explain what is the difference between the two, and how the blockchain is constructed and how it is related to Bitcoin. So first of all, the motivation for creating the blockchain. There has been a growing need for digital payments. E-commerce became very popular in the 90s after the internet started becoming popular. Companies like PayPal, Amazon, all of these companies were established in Silicon Valley, and they started offering services where you can make purchases online. E-commerce became very popular towards late 90s and early 2000s. And there was always a great need for making payments digitally. So the growing need for making these digital payments, it led to a number of challenges. Some of those challenges are requiring intermediaries, such as the banks. Whenever you want to make a payment, so if you go to Amazon.com and you make a payment, there are actors acting in the back. Banks are some of those, Visa companies are some of those, and these intermediaries can censor the payments, can reverse the payments, can prohibit the payments, and may not always be online. It has happened to many of us when you go to transfer money to some of our friends, that the banking system might not be online. It doesn't happen in the outside world. It does happen in Pakistan, and we can't avoid that. So it would always be the case that this intermediary, either it will prohibit the payments, will censor the payments, or may not be online. So this will require that I should be able to make a payment to you directly in a peer-to-peer manner without the intervention, without the role of a central intermediary, a bank. If I am able to make a payment directly to you, well, of course, the physical currency is an example of that. I can have 100 rupees note and I can give that to you without the intervention of an intermediary. So that is also a peer-to-peer payment. Of course, the physical currency is issued by the central bank, so there is a central bank's role there as well. But the payment is direct, is peer-to-peer. Nobody can control that payment or prohibit that payment. But with the peer-to-peer digital payments, the matter of double spending comes up. And what is double spending? Double spending is a problem. It's an inherent problem whenever you have payments that are digital as well as peer-to-peer. If the peer-to-peer payments are in physical currency notes, there is no problem of double spending. And the current banking systems are like that. They are either peer-to-peer by using these physical currency notes, or digital. I can transfer money by using my banking app to you, which is a digital payment, but it is not peer-to-peer. There is an intermediary in between. So either peer-to-peer or digital. When you have both of these, then the problem of double spending will come up. If I have a digital note with me, which is just a sequence of bits, some data stored on my computer. I can give that data to Afaq, I can give that data to Tariq, I can do the double spending there. And double spending has been a problem in peer-to-peer and digital systems. The other problems which are associated with direct peer-to-peer payments are missing financial freedom. Whenever you have banks in between, there have been several instances, and the most recent one, the bigger one, was the bailouts in 2008 when the financial system crisis globally happened, and governments came up to back these banks and use the taxpayers' money to bail out the banks, And people are not happy about it. Why these people are being bailed out? By using our tax money. And also there was another challenge is the complicated global transactions. Whenever you need to make the transactions internally within a country, then the transactions can be fast and cheap. So for example, the RAS system in Pakistan, which has been in place for a few years now, allows you to make fast payments and cheap payments. Compared to the previous system in which you had to spend some money at the back end. It's not that you have to spend the money, but the money was spent. The settlement was late. It would take a day or so. So RAS has made it very easy, fast and cheap, You want to do that globally, internationally. I want to transfer money. You want to transfer money from one country to another country, another continent to another continent, in exactly the same way. The current system does not support that. We have to go through these payment rails or banking rails, which are based on SWIFT or Western Unions, or maybe Hawala or something like that, which are slow, which are not cheap, which are expensive, 2, 3, 4, 5%, up to 5% of the money which is remitted can be gone in the fees. But we are in need of fast and cheap transactions globally, internationally. Okay? So these are some of the challenges which were faced with the growing need for digital payments in a peer-to-peer manner. And to address some of these challenges, plus some more challenges, the first blockchain was created in 2009. The paper came out in end of 2008. January 2009, the first blockchain was created. And this first blockchain which was created, it was created by this anonymous guy, still anonymous, Satoshi Nakamoto. Many people have tried to estimate who Satoshi Nakamoto is, and I will not go into those predictions. But the guy still remains anonymous after the creation of this blockchain in 2009, which is the fundamental for the Bitcoin technology. And we'll talk about Bitcoin technology in a little bit. So what exactly is blockchain? Before we talk about the Bitcoin, let me just get the definition of blockchain out of the way. So the blockchain is a ledger of recording the data. What I'm showing here is a ledger in Urdu. Some of you might have seen this. I have seen this when I was a young kid at my father's shop. So this kind of a ledger is used very frequently in Pakistan, where you record all the transactions, mostly written in Urdu. So a blockchain is also a ledger which is used to record transactions, just like you would do in this old-fashioned way. However, in blockchain, you will do it across a network of computers. You have these computers spread throughout the internet, in many countries, in many cities, many continents, and you will store these transactions, record this data across a network of computers in a distributed way. So that's why it's called a distributed ledger. The term is very often used. You might have heard of this term a number of times, and this is exactly what distributed ledger means. We'll go into the structure of the blockchain as well. The two fundamental questions about the distributed ledger or the blockchain is who initiates or generates those transactions. We know exactly who writes the transactions in this kind of an Urdu ledger. The owner of the shop would write these transactions here. But in the case of blockchain technology, who will initiate or generate those transactions? Any node or any computer in this distributed network of machines which are running this piece of software, which is using those software, this machine is acting as a node on the blockchain network. Any of those nodes would be able to generate those transactions. This could be an individual. Doing it himself or herself, or it could be a work delegated to an exchange. So for example, you can create an account at Binance or Coinbase and they will do it on their behalf. Or you can keep your wallet on your computer, run this little piece of software which is freely available, open source. You can run it on your machine and you can generate these transactions from your machine to be spread on this blockchain network, on this distributed ledger, which is maintained by the rest of the world. Which leads to the second question, which is who maintains or stores this distributed ledger? In this case, this ledger is maintained by the owner of the shop. But in the case of a distributed digital ledger, who maintains that? And this ledger is maintained. The answer to this question is again very simple. This question is very often asked. Most nodes, this little piece of software, they will keep a part of the ledger. And some nodes with greater capabilities, greater storage capabilities will keep the full ledger. The full ledger will be stored with that. So why is it called a blockchain? Why is it called a blockchain? And there are two words here, block and chain. And the reason that it's called a blockchain is exactly because of those two words. So it's a block of data. Because of the structure, so blocks of data in which we have transactions written. We have shown 3 blocks here in which you have some number of transactions. Every Bitcoin block, again, I'm jumping ahead. We have not explained Bitcoin. Every Bitcoin block will be something like this. You will have block after block, block after block, and these blocks will contain transactions. A Bitcoin block will contain maybe 2,000 transactions, 1,500 transactions, 3,000 transactions, something like that. So we're showing 3 blocks here, block 55, 56, and 57. Currently, Bitcoin blockchain has about 1 million blocks, a little less than 1 million blocks, okay, since 2009, Okay. So we have these transactions written in these blocks of data. So these blocks are somehow chained together, which will make it a blockchain. And what is the chaining process? This chaining process is through what we call cryptographic hashing. And what is this cryptographic hashing? It's very simple to explain. Cryptographic hashing, we'll consider a cryptographic hash function like a black box or a blue box in this case. It's a black box which will take any input, and this input could be some small text or could be a whole book. So this could be any size text as input to this cryptographic hash function, and this cryptographic hash function will result in a fixed length hash output, some text which you will not probably be able to make sense of it, but some numbers written here of fixed length. So it doesn't matter what the input size is, the output size for this cryptographic hash function would be the same. It's a complicated mathematical function. We'll not go into the detail, can't go into the detail of this lecture, which is 50-minute long, now reduced to maybe 30 minutes. But we'll try to go 50 minutes maybe. So how is this hash computed? The hash is computed. Every computer, whether you use Windows or Mac or Linux machines, they will have this software installed by default. You can compute the hash of any input text. These functions will be available on your machine. You can easily compute that. Provide any input. In this case, I'm providing the input hello, and this is the output here. There are websites. This is taken from a website. There are websites that you can go and you can provide an input text, and the hash will be created. And this hash will be created according to some standard. In this case, I'm using a standard which is called the SHA-256 standard, which is one of the most popular ones, which is used in the industry. So this hash is calculated by this piece of software, which is either installed on your machine or you can access on any website. So if you make a change in the input text, if it is hello 1, you will see that there is a significant change in the hash output. So if I change it to hello 2, significant change will happen. Slight change in the input will completely change the output of this hash function. So how do you chain the blocks? By using these hashes. How are these hashes used to chain the block? We said that we have blocks which have transactions, and these blocks are chained together by using these cryptographic hash functions. Now we know that cryptographic hash functions, they will take any input and they will give you a fixed length hash output. How are those hashes used to chain these blocks together? So each block in a blockchain will contain the hash or digest, as we call it, of the previous block. So all the data in the previous block, I will feed that into that black box or blue box, which will compute the hash function, and that hash output will be put in the next block. So if you have block 55, which has a number of transactions, it will contain this extra data, which is the hash of the previous block. Of course, you will calculate the hash of this entire block again, including the previous hash, because this is now the data which is contained by this block 55. 76 transactions plus this previous hash, and you will compute the hash. Maybe the hash output comes out to be this fixed length hash output, this hash number. You will use this hash as a previous hash value into the next block. Similarly, you will calculate the hash of block 56 and put that as the data in block 57. So that's how you will use these hashes to compute the hash value of a block and put that hash value into the next block as this additional data. So this is your blockchain. Of course, when you use these hash functions will have some properties. Because of those properties, this blockchain will have some properties. And two of the very fundamental properties of the blockchain is that the transactions that you write on the blockchain, they become immutable or almost immutable. You can't change those. Unlike the ledger, where you can cross things out, you can put some blanco on those transactions, you can't do that in the blockchain. Once something is written on the blockchain, it is set in stone. How do you undo it? You can't undo it. The jugaad way of undoing it is that if I give you $10 and you want to undo that, you give me back the $10, I will record both the transactions. I will record both the transactions on the blockchain. Okay? So hashes in a practical blockchain, they need to meet some criteria. How do we get these properties from the blockchain? So we restrict the hashes to meet some criteria. And one of the examples of this criteria is that the hash value should start with 3 zeros. Now, remember that blue box which was calculating the hashes, which was acting as a black magic, you can't control the output. You can control the input. You give it an input and you don't know what output you will get. Okay? So how do we get this 3 zeros? I want the output value of the hash box to start with 3 zeros or 5 zeros or 7 zeros for that matter. Okay? What if the criteria is not met? So you have this block 56 which has 43 transactions and the previous hash value, and you take the hash of this block, this comes out to be this number, which does not satisfy the criteria. If it doesn't satisfy the criteria, what do? This block will not be allowed on the blockchain because it is not meeting the criteria. How do you force it to meet the criteria? Well, change the input. Change something in the input. I can't change this previous hash value because this is the hash value of the previous block. I, of course, cannot change it. Can I change these transactions? Well, these transactions cannot be changed. If Heather gave me $100, I don't want it to become $99. I want the transaction to remain intact. Everyone would want the transactions to remain intact. We don't have the luxury to change these transactions. Okay? So if we want to change something in the block data is fixed. We are restricted that everything is fixed here. What do we do? Well, we introduce this arbitrary number or a fictitious number, which we call number only used once, nonce value. This nonce number is included in this block. This number doesn't do anything. It's not part of any transaction. It's not the previous hash. It's just an arbitrary number that you have just introduced in this block of data as this additional field. Will not help in any transaction, will not be part of any transaction. Okay? So what happens then? When you introduce this arbitrary number, so you have changed this block data. If you take the hash of this guy, this will be a new value. Maybe it will meet the criteria. But if the hash value still does not meet the criteria when you introduce this arbitrary number, what choice do you have? So change something. I can't change any of the transactions. I can't change the previous hash value. But this is an arbitrary number. I can change it. I can change it. So let's change it. So keep changing the nonce, keep changing the nonce until the criteria is met. Until the criteria is met. If it's only a 32-bit number, it's a very small number. No? It will take 2 to the power 32, which is 4 billion attempts. 4 billion attempts to go through the entire nonce cycle. There are machines which will be doing that for only for 32-bit number. If you have a longer number, if you have a 160-bit number, it will take you almost forever to go through those cycles. This is where you will be searching for this nonce value using which you will meet this criteria. You will meet this criteria. I know Afaq is smiling because these guys go through these nonce. Spend energy, run through this computer, trying each nonce value, one after the other, hoping that some nonce value will result in this hash value to meet that criteria that we have set there. Yeah? This is the process of mining. We all have heard about mining. Mining is not generation of Bitcoin. Mining is finding this nonce which will allow you to have a block which will meet this hash criteria so that it is eligible to become part of the blockchain. Eligible to become part of the blockchain. So this is the mining process. So we have a lightning talk arranged for tomorrow by Afaq. We'll be talking about the mining process and how they have the license to do this in Pakistan. So the first and only license here. They're already doing it outside Pakistan. ज़्यादा तो नहीं बता दिया. काली गाड़ी खड़ी है इनके लिए. Okay, so this is the mining process. So quick recap of what we have said so far. Transactions, blocks, and hashes. It's always good to recap. So each block in a typical blockchain will contain transactions, hash of the previous block, and this arbitrary fictitious number nonce that we have adjusted. I will not adjust that. Some miner will adjust that. Some miner will adjust that, who will have this huge computer on which they will be running, checking these nonce values one after the other, looking for a good nonce using which the hash criteria for that block will be met. Okay? So each block will contain these transactions, hash of the previous block and the nonce, and the hash of this block will be put in the next block, hash of this block will be put in the next block, and so on and so forth. And going through this nonce, cycling through this nonce to meet that hash criteria, this is the mining process. This is what we have talked about so far. Okay? Very simple, very simple. No Bitcoin yet. No Bitcoin yet. We'll talk about Bitcoin. We have a complete session on Bitcoin and Ethereum. Dr. Naveed will be talking about that. Okay? You will still not be able to get the investment advice after this summit. Okay, you'll be on your own for that. We'll talk to you enough about Ethereum and Bitcoin, but when is a good time to invest, nobody will know. So how is a block added to the blockchain? So let's say we have a user A, and this is currently the state of the blockchain as it is seen by user A, and user A wants to add a transaction to this blockchain. You don't add a transaction to the blockchain, you add a block to the blockchain which contains these transactions. Okay? One of those transactions is generated by this user A. Let's say this user A is willing to pay $5 to user B. They both agree that this amount should be incorporated into the blockchain. This transaction should be added to the blockchain. What A will do is that it will broadcast that transaction. Remember, this is a distributed network of computers spread throughout the internet. So user A have a computer, piece of software running, A will just broadcast their transactions. If A doesn't want to do that, can outsource that work to Coinbase or OKX or some other exchange or Binance. They will do it on A's behalf because they will have A's account with their custody. So these transactions will be broadcasted and will become part of this unconfirmed, what we call transaction pool. So large pool of transactions. These are unconfirmed transactions, not part of the blockchain as yet. Not part of the blockchain as yet. Okay. A miner, which is probably controlled by a FAQ, my friend, will pick up some of these transactions, There might be some logic of picking up these transactions. These transactions might offer a small transaction fee that if you confirm this transaction, make it part of the blockchain, we will give you this small amount of money. Maybe who is giving more money, I will just prefer to pick their transactions. So we'll pick some of these transactions. The miner will pick these transactions, will do the mining process, going through that nonce and fulfill this criteria. Once the criteria is met, this would be a block which is eligible to become part of the blockchain. This miner will advertise or broadcast that block which meets the criteria, which has a hash which meets the criteria to the blockchain network. Everyone will listen to that. This would be broadcasted. Okay? Still not part of the blockchain. We are hoping that this will become part of the blockchain, but maybe not yet. Okay? It is not confirmed as yet. Okay? Because just like this miner, there may be other miners sitting in the world at different locations. They might also be trying to mine this block. If this is block number 76, everyone in the world at the same time is trying to mine block number 76. Why is everyone doing that? What is the incentive for the miners to do that? Because they get a reward. They get a reward for mining a block. Okay? And that reward is given in terms of cryptocurrency. That's how you tie the Bitcoin with the mining process. We call Bitcoin as digital gold, but it is slightly different from mining gold. If you mine gold, you get the gold. If you mine on a Bitcoin blockchain, you are mining the blocks, you create the blocks. In exchange for creating or mining that block, you will get this money in terms of Bitcoins. Okay. So this block is broadcasted to the entire network and then it will get some confirmations. What do we mean by confirmations? Confirmations means that you will add blocks after this block. So somebody else will go through the mining process, and after this yellow block number 76, they will add a block 77, which is an implicit endorsement that this yellow block, I accept this yellow block. That's why I'm adding this green block after that. If you don't accept this yellow block, you would not add a green block after that. Once you add this green block, now it would become slightly difficult to change this yellow block. If you, after this green block, you add 10 other blocks, it will become almost impossible to change anything in that yellow block. Okay? So adding a block subsequent to this yellow block is an implicit consent. All the miners, they have consented by using this consensus mechanism that this yellow block, we accept it. This is how the consensus is achieved. When we talk about blockchain and Bitcoin, the term consensus is often used, and this is exactly what we mean by consensus. This is implicit here. Okay? So what does blockchain bring to the table? By using those cryptographic hash functions and chaining the blocks one after the other, what do we get at the end of the day? What is the blockchain bringing to the table? One property of the blockchain is immutability that I already talked about. That means it becomes nearly impossible to change or roll back transactions, which is ensured by these hashes, If you want to change a transaction, that means you are changing the data within a block. And when you change the data in a block, the hash value will change. If the hash value will change, that means this hash value goes to the next block. The data in the next block is also being changed. When the data in the next block is being changed, that means the hash value of that block will also change. So that means if you make a change in a block, you will have to make changes in all the subsequent blocks, all the subsequent blocks. Okay. What if someone is actually able to do that? Well, we have this distributed, decentralized mechanism. Everyone is trying to create these blocks, will stand against it. The other property of the blockchain is auditability. No, it's transparency. Everything is available. Bitcoin blockchain was created in 2009, Ethereum a few years later. All the transactions which have been created on these two blockchains and many, many other blockchains are completely publicly available. Everyone can see those transactions all the way back from 2009. So auditability is the other key property. Immutability and auditability is the key property of all the transactions. You will be able to see all of these transactions. Okay? And then, of course, decentralization. You have these nodes distributed across the globe, across the internet, and these nodes are working in a decentralized way. Nobody is becoming party with the other, and this will enable autonomy and the censorship resistance. We don't have a bank or a third party or central entity in between. People will be able to make these transactions without any central entity. And this will reduce the single points of failure, or if this central entity is not online. What about privacy and anonymity? Well, as I said, all of the transactions on the Bitcoin blockchain or the Ethereum blockchain, since they were created, are available online. You can just go it and see it. You might not be able to see who is making this transaction, but you will be able to see what address. Everyone is allocated an address. What address is making these transactions? All the transactions are transparently visible. Transparently visible. So privacy is pretty much gone. Privacy is pretty much gone. However, anonymity is still maintained. You know which address is making transactions all the way from 2009 until today, but you don't know exactly who that person is. So privacy is largely gone and anonymity is largely maintained. There are ways that you can break the anonymity as well by doing chain analysis. We won't go into the detail of that. We have a whole semester course about that where we talk about it. So going beyond the storage, in the traditional sense, a database is used for storing the data. Blockchain also stores the data, and people have misused blockchain in place of database, replaced their databases only to bring inefficiency to their systems. Okay. Storing data in blockchain is much more inefficient compared to the database, but there are certain properties that blockchain will bring which older database systems will not be able to bring, and those properties are immutability, auditability, and decentralization. So very quick discussion. So I'll try to wrap up and continue with my session. Bilal is here, most welcome. So I will continue with the session after his chair. So let's try doing these financial transactions without a bank, and let's consider an example of a tribe on an island a couple of thousand years ago. How would they build their financial system? How will they exchange things? Well, barter was one of the ways, but they wanted to evolve from the barter system. They wanted some sort of a financial currency that they can use to buy things. There are inherent problems in the barter systems. Granularity is the biggest problem in the barter system. If I need 1 kilo of rice, I can't give you a goat for that 1 kilo of rice. So obviously there is an issue. There is an issue there. We want fine granularity, smaller currency nodes, something like that. So how would these people build a financial system 2000 years ago, evolving from the barter system? So let's say everyone is given 20 precious stones. Maybe these stones were allocated by the government. And the transactions will be made using those stones. If I need some rice, I will give you 2 stones and I will get rice. If you need some wheat, you will give 3 stones and will get some wheat. So these stones will be acting as the currency, offline currency for you. This is very similar to the currency notes that we have. This is printed fiat that we have. I can go buy yogurt and give them 200 rupees or 300 rupees, whatever is the price of yogurt these days. So this system is very, very similar to the printed fiat system that we have. 2000 years ago, people were able to do that. But think about it, do we really need those stones physically? Can't we just agree that everyone starts with 20 stones and those are the virtual stones? Nobody has physical possession of these stones. There's just 20 stones virtually allocated to everyone. That might work, but there might be a problem. The problem might be that I might claim that I have not spent my 20 stones, but in fact I would have spent some of those stones. So if they were physical, just like currency notes, I would have been able to avoid the double spending. But if these stones are virtual, I would not be able to avoid double spending. So how do these people in this tribe 2000 years ago with these virtual stones be able to make the transactions and bring immutability and bring auditability and do it in a decentralized way? How would they do that? Well, if I spend 3 stones and buy rice from Afaq, how would I do that? Or from Khurram, who is the CEO of Pakistan Mercantile Exchange. So it's more appropriate to buy rice from you than to him. Yeah? So how would you do that? Well, physical stones agar nahi hai, what do we do to get auditability? Auditability means transparency. Everyone knows that this transaction has happened. I have spent 3 virtual stones to get the rice from Khurram. How would I do that? Well, Khurram and I might go to a mosque, on that island and announce on loudspeaker so that everyone listens to that. This is like broadcasting in blockchain. It sounds like that. No? We'll just announce that and everyone will make a record that I have spent 3 stones, now I have 17 stones left and the rice are in my possession. What about immutability? Well, we can make a rule that in the mosque you cannot undo a transaction. We can't announce that the rice that I had purchased from Khurram, by spending those 3 stones, let's undo that transactions. Let's forbid that kind of transactions. Well, we can still make a transaction where we announce that yesterday the rice that I had purchased using 3 stones, Khurram is buying back those rice. But now I will need 4 stones to give you back that rice. Itna profit to banta hai. Yeah? So I will make another transaction and we will announce that in the mosque as well. So we have auditability and we have immutability by using this rule. In this old system, 2000 years ago in a tribe, this is your poor man's blockchain. This is your poor man's blockchain. It's exactly the same thing. So we gave the example of a poor man's blockchain by considering an island where there is a tribe 2000 years ago. How do they achieve consensus? The same consensus options are available in the present day blockchain as well. And the consensus is needed because we need to develop this distributed ledger. It's not one centralized ledger, it's a distributed nodes which are keeping copies of the data or partial copies of the data. So they must be in consensus with each other. So how is this consensus built? This consensus is built in many different ways. The first popular consensus option is proof of work, We have gone through the process of proof of work without actually naming it. Finding this nonce value which will make a block to satisfy this criteria is actually the proof of work. You are doing some work by going through these gazillions of nonce values to find this right value of nonce which will satisfy the criteria for that block, and you are doing this work using a heavy duty computer with GPUs and all that, and this is a proof of work. This proof of work is used in Bitcoin blockchain. Bitcoin blockchain, which was the first public blockchain which was made available. Block creators in this case are called miners. When they create a block by picking up some transactions and putting those transactions inside the block, going through this nonce value, when they create a block, they will get a reward. And the reward in the present day is 3.125 bitcoins. It's a small amount. Multiply that with the $70,000. So it's about $210,000 these days. When Bitcoin blockchain was launched, this reward used to be 50 bitcoins, 50 bitcoins, and it halves every 4 years, roughly 4 years. Okay? The other second popular option for the for the consensus is called proof of stake, in which case you don't consume the power, but you need to have the stake in terms of cryptocurrency. And once you have this cryptocurrency in exchange, you get the opportunity to create a block. Once you create a block, you will get a fee, and that's how you create the block. This is the option which is popular with Ethereum. Ethereum many years ago was also using proof of work, but these days it's using the proof of stake blockchain. Now, how are these bitcoins or Ethereums, this currency is created? This currency is not created by the government. This currency is created by the system. And for example, in the Bitcoin blockchain, when you mine a block, as a reward for mining that block, for putting all those transactions in, you will get 3.125 bitcoins, which is newly created Bitcoin. It's very easy to create that from the system. Why? Because all you need to do is just put a transaction in a block that this guy who is the miner of the block is getting 3.125 bitcoins. This is just a transaction, just like a regular transaction that I'm transferring some bitcoins to Tariq. That is also a transaction which goes into the blockchain in one of the blocks. Similarly, this reward amount is also written as a transaction inside the blockchain. So Bitcoin and Ethereum blockchain represent what we call the permissionless blockchains. Anyone can join. Anyone, it's open to the public. Anyone can read or write or update the ledger. Anyone in the world can install this software, and they will be able to create this block, pick the transactions from the pool, put those on the block, and the block will be added to the blockchain. And then we also have these permissioned blockchains used by several banks, JP Morgan, for example, in which anyone can read, but only authorized nodes will be able to write the blocks or write transactions to the blockchain. You can have permissioned blockchain as public or private. In the case of private, nodes can read or write based on only their authorization. Of course, you cannot have a permissionless and private. If it is private, it can't be permissionless. So, when not to use a blockchain. About 10 years ago, a lot of funding was raised in Silicon Valley. Many companies came up with ideas built around blockchain. They wanted to use blockchain. As we saw that blockchain is used for storage of data. Since blockchain is used for storage of data, it was very easy for people to think that we can replace an old database system by a new blockchain system. But we see that database systems are generally very efficient. Even if they are distributed, they are still very efficient. Blockchains, since their data is distributed, ledger is distributed among many different nodes spread throughout the internet, the storage and extracting that data, verifying that data is very cumbersome. It's very inefficient compared to a centralized database. Okay? So the first question is that for a particular situation, do you want to use the blockchain or not? Okay? Now, when these companies were created, many of these started using the blockchain without using the true benefits of blockchain. It was not required for their applications, but they still tried to use blockchain. Many of those companies, you probably would not hear the names of those companies. They are defunct, gone bankrupt, that capital is lost. A couple of companies survived. If you asked me 10 years ago, what is the best use case for blockchain? There was only one use case for blockchain, and it was cryptocurrency. That was the only use case for blockchain. In the last 3, 4, 5 years, many new use cases of blockchains have come up. One of those is stable coins. The other one is tokenization of assets. These use cases have become very popular, are in broad use. Tomorrow we have some demos which will talk about banking use cases. How can you do the remittance? We talked about remittances with Bilal, how the remittances can be made. Currently, we can't do the remittances to a bank in Pakistan, but what is needed to make those remittances in Pakistan? Somebody sitting in the US is willing to send USD to me. They have traditional banking channels available, a SWIFT channel available. If they are sending $100 to me, 35 of those will be deducted, plus some other fees. So 50 of those will be deducted when they send $100 to me. If they're sending $100,000, probably $50 is not that big of a deal. Time is still a big deal because it will take 3 or 4 days through the SWIFT system or the traditional rails for that money to land in Pakistan. Can we do this efficiently and cheaply? Okay? Can we do this instantly, maybe within few minutes, or without spending these $35 per hop on SWIFT banking? So we will talk about that tomorrow. Right now, I'm just going to show you a slide which will try to highlight what are the 99% situations when the use of blockchain is useless. So if you need to store some data, need to store some state, you should ask this question, whether you need to do that. If you don't need to store any data, there is no point in using a blockchain. There is no point in using a database. There is no point in using a file. You don't have to store anything. तो कुछ भी शायद use करने की ज़रूरत नहीं. But if you need to store some data, then you need to ask the question whether you have multiple writers. Do you have multiple writers? If you don't have multiple writers, there is no point in using the blockchain. In this case, this is one single writer, trustworthy writer. If there are no multiple writers, there is no point in using the blockchain. But what if you have multiple writers? If you have multiple writers, then you need to ask the question, do you have an online trusted third party available? And it is available always, guaranteed 100% of the time. If that trusted third party is always available, then you still don't need to use the blockchain. Remember, we used the blockchain because we said that there is this party in between which is either not trusted because the banks can go bankrupt, because the banks can fail, because the government will use the tax money to save those banks. In that case, it is not the trusted third party. But if it is trusted third party, they guarantee you that the banks will never fail and they are always available online. In that case, you don't need to use the blockchain. However, if this condition is not true, then you need to see if there are multiple writers, are these all writers known? So you might have a company where you have 3 or 4 database administrators, they are all employees of that company, they are all trusted, and these are all known. If all of these writers are not known, that is the case. You don't know how many people will be writing there, which is the case happening in the case of Bitcoin blockchain. You don't know how many people will be writing transactions or mining the blocks on the Bitcoin blockchain. That is the case when we will use the permissionless blockchain, used in the case of Bitcoin, used in the case of Ethereum. If all the writers are known to you, which is the case of an organization which has 4 or 5 database administrators who are managing the data, if they are all known to you, then you need to ask the question, are all of these writers trusted? Normally, this is the case in an organization. If you're working for a bank, all the people who have access to the data, they are trustworthy people. If they are all trusted, then you still don't need to use the blockchain. If they are not trustworthy, all of them, you know the number of people who have access, but not all of them are trustworthy, then that is the case where you want to use the blockchain, but you need to ask the question that do you need public verifiability? If you do need public verifiability, then you need a public permissioned blockchain. If not, then you need a private permission blockchain. So you see that there are lots and lots of cases where the use of blockchain is not required. Not just not required, it will just add inefficiency to the system. There is no point in using that. But there are some specific cases where there is no alternative. You have to use the blockchain in those cases. So I will skip this slide. By the way, many of these slides will be available. If you guys can send an email to Cedar, they can share the slides with you as well. So in the interest of time, I will see what else I would like to talk about. So there is this little concept about the Bitcoin. Bitcoin is always locked to the owner. The Bitcoin is always locked to the owner. The amount of Bitcoin that has been created, every Bitcoin is created only when a block is mined, when a block is added. About 1 million blocks are on the Bitcoin blockchain. Every time a block is added, some Bitcoins are generated by the systems and given to the creator of the block, And in a transaction, the pair will unlock, only they will be able to unlock, and we can do that by using some cryptographic functions. Only they will be able to unlock that transaction, and it will lock to the pay. So for example, if I want to pay something to Tarek, I will unlock my funds, 2 Bitcoins, and will lock those in Tarek's name. And minting of the new BTC, as I said, it happens only at the time of Bitcoin creation and at no other times. No new Bitcoins will be created. There is a maximum supply of 21 million. We are close to 20 million. And it will get locked to the creator of the block, who can then spend it to for other purposes. So I will skip this as well. Let me very quickly talk about the smart contract as well. Smart contract is a contract, just like you have a regular contract between 2 parties, and you might have an escrow looking after that contract. This is a contract which will stay on the blockchain, and blockchain itself will act as an escrow. And in the case of smart contracts, when the conditions are met, so for example, if you bought an insurance contract, you will pay the premium and somebody will pay the payout, and that amount, your premium and their payout, will be locked into the smart contract. If the insurance conditions are met, if you have bought that insurance and some accident happens or something like that, if the insurance condition is met, the payout will be made to you, otherwise your premium will be gone. So there is a lot more to smart contracts, and Dr. Naveed might be able to talk about smart contracts a little bit more. We'll skip this. So I'll just take another couple of minutes to talk about the more recent trends in the crypto area about stable coins and tokenization. So this was the news from a couple of days ago that Facebook offers money to the creators who create content on Facebook. So Meta has started offering USDC payments to the creators in tokens. This news was a couple of days ago only. In Colombia and Philippines, they are doing this pilot, will extend to 160 markets. So Meta is rolling out payments in USDC using Solana and Polygon. These are 2 blockchains similar to the Bitcoin blockchain, in partnership with Stripe. And Stripe is a company payment provider. Why they are doing this? They are doing this for faster and low-fee international payment. Faster and low-fee international payments. Tomorrow's demos are also about faster and low-fee international payments. How do you make remittances to countries outside your country? And the previous failed attempts from Facebook was about these Libra and Diem a couple of years ago, and they have abandoned those projects of stable coins. There was another news also a couple of days ago, and this also includes Stripe. I just included it here because this was also about Stripe. So Stripe is probably a company to look for. It's not a public company. You can't buy Stripe stock. It's a $160 billion. Yeah, for now, yeah. I think this one can also be skipped. So I'll quickly talk about stock tokenization. You can tokenize lots of other things. Commodities can be tokenized, real estate can be tokenized. Very quickly talk about stock tokenization. So if you're sitting in Pakistan and if you want to buy Apple stock from NASDAQ or New York Stock Exchange, will you be able to do that? Maybe a few people will be able to do that, but most of the people will not have access to that stock. What if I tokenize the stock of Apple and offer those tokens? Since these tokens are globally accessible, you will be sitting in Pakistan or Dubai or Malaysia and will be able to easily buy the stocks of Apple. So for example, if you have this customer sitting in Pakistan, this guy will access a virtual asset service provider in Pakistan and will order that buy me $50 worth of Apple stock or whatever equivalent of Pakistani rupees is there in tokens. In tokens. They can't buy the Apple stock, but they will be able to buy these tokens. Typically, this virtual asset service provider who is residing in Pakistan has a license from Pivara, would not be Securities and Exchange Commission regulated. They can't buy Apple stock. They are not regulated by SEC, which is the equivalent of SECP in the US. So these guys will not be able to buy the stock. They must partner with a stockbroker in the US who is authorized to buy stock and hold custody of that stock from New York Stock Exchange. Okay? So this guy would be SEC regulated safe custodian of securities. So they will enter into a smart contract with each other. So this guy will then access the New York Stock Exchange, will buy Apple stock, $50 worth of Apple stock, and will hold custody of that and send a message to the smart contract that the order is fulfilled, you mint a token and release the payments. And the payments will be released, this user will get the token, and the end user will get access to this stock in the tokenized form. The benefit is that they will be able to exchange with anybody, okay? And can also perform direct trades with other users. So similar to this use case, we will talk about the tokenization of real currency, stable coins, how stable coins can be used for remittances from the US to Pakistan. We'll not talk about Pakistan. We are not there yet. We'll talk about UAE. We will have an example of UAE, and then we will have some lessons for us. You know, what the financial institutions in Pakistan might need to reach the same place where somebody sitting in New York would be able to send $50 instantly without much fee, would be able to send that money and can be converted into PKR in Pakistan. So tomorrow morning there are a couple of demos about that. So just wait for that. ज़्यादा time ले लिया. हाँ, उसके ऊपर नहीं बात करें. Yeah. Yeah. So I will stop here. I've already taken some time from Dr. Naveed's session. Dr. Naveed is here. हाँ, यहाँ बैठे. Naveed साहब आ जाए.